Hi, welcome to The Explainer. Let's just jump straight into this, shall we? Today, we are going to explore how you can build powerful, automated, and entirely local AI workflows, all without sending a single byte of your sensitive data to the cloud. We are looking at a really revolutionary combination of tools here, All-Alma and the Model Context Protocol, or MCP. If you have ever wanted an AI that works for you, completely privately, well, this is your blueprint. I mean, just imagine it for a second. Having a fully capable AI assistant running directly on your own hardware. We're talking about an AI that can search the live web, read your local files, and actually execute code. And the best part? It's completely free of expensive API costs and those nagging privacy concerns you get with cloud platforms. For a long time, this kind of truly agentic behavior was locked firmly behind paywalls. But honestly, not anymore. To keep us on track, we are going to hit 6 key areas today. We'll start with local agents without API costs, then look at the brains, our tool calling models, and how to bridge those models and tools. After that, we'll pick an MCP client, dive into some advanced agentic features, and finally wrap up by actually building your own agent. Okay, Section 1. Local agents without API costs. Let's start by understanding the anatomy of a local AI agent and why this specific architecture is an absolute game changer. I absolutely love using this biological analogy because it brilliantly illustrates how these distinct software components talk to each other. Your local large language model, that's the brain. It thinks, it reasons, it decides what needs to be done. The tools, like a web browser or a file reader, are the hands. They actually interact with your environment. But until recently, the brain and the hands couldn't easily coordinate. A brain in a jar can't do much, right? They were totally disconnected. And that is exactly where the nervous system comes in. That nervous system is built on the Model Context Protocol, or MCP. This is an open standard, and it's a huge deal. Instead of having to write custom, tedious integration code for every single app you want your AI to use, MCP acts as the universal language. It finally allows our local, isolated AI brains to attach hands and actually reach out into your system. Moving right along to Section 2, the brains are our tool calling models. Not every language model is built the same, so we need specific local models optimized to actually understand and request tools effectively. When you look at the top recommended models you can pull via All-Alma, it's fascinating how specialized they are. Take the QN 2.5 7 billion parameter model. Developers highly recommend this one because it handles complex JSON tool requests incredibly reliably. Alternatively, Google's Gemma 2 offers a super high-performing architecture in multiple sizes. There's even a really cool specialized community fork called cow/gemma2-tools that modifies the system template specifically to support tool calling. Oh, and a quick tip. If these models try to call a tool that doesn't exist, just feedback a tool not found response. It keeps the whole loop running smoothly. Section 3. Bridging models and tools. With our brains selected, we need to bridge them to our hands. This is where we attach the external MCP tools that do the heavy lifting. There are some incredible official MCP servers you can run that give your local model massive reach. It can search the live web using the Brave API, read and write securely to your local file system, manage your GitHub repositories, or, and this is wild, even physically control a web browser using Playwright. But attaching them correctly to your local model requires a very specific flow. This flow builds what we call the agent loop. Think of it as a continuous 4-step cycle. First, your All-Alma model outputs a JSON request asking to use a tool. Second, your client intercepts and parses that request. Third, the external MCP tool, like your file reader, actually executes the action. And fourth, the result feeds right back into the model. The model reads that new data and decides if it has the final answer or if it needs to issue another tool request, keeping the cycle going. Section 4, choosing your MCP client. To actually run that loop, you need a software bridge, your nervous system, and you actually have several great open source options to pick from depending on your technical vibe. If you're a developer wanting to tinker in TypeScript and study multi-server routing, Butruff's MCP LLM Bridge is a fantastic standalone option. If you prefer Python, Jonigal's All-MCP client offers a beautiful terminal UI and active maintenance. And if you are a command line purist who loves Go, the Kit project by Mark III Labs provides an incredibly robust CLI with built-in tools like Bash and grep right out of the box. Section 5. Advanced Agentic Features. Okay, let's dive into the advanced features that the Python and Go clients unlock for power users, because this is where things get really exciting. Both MCP and Kit pack a massive punch. They offer an agent mode, which allows the model to iteratively call tools in a loop, with a configurable limit, of course, so it doesn't get stuck forever. They offer hot reloading, which is an absolute lifesaver for developers because you can tweak your custom MCP server code without restarting the client. They even auto-discover your existing Claude configurations. So if you already use Claude Desktop, your local agent instantly inherits those tools. Kit even allows you to spawn sub-agents from multi-agent orchestration. It is incredibly powerful stuff. But, with all this autonomous power comes a significant risk. What if your AI agent goes rogue and accidentally deletes crucial files or pushes bad code to production? That is where human in the loop, or HIL, comes in. It's the critical safety mechanism you absolutely need to know about. Here is exactly how you safely audit your agent's actions using a client like MCP. When the model requests a tool, the client just pauses execution and prompts you right in the terminal. You get to review the exact JSON command. From there, you just press yes to approve it, no to skip it, session to auto-approve tools for the rest of that specific query, or abort to pull the plug entirely. It gives you complete peace of mind while your agent does its thing. Finally, Section 6, building your own agent. Let's talk about the practical steps to actually get this setup running yourself. It's really just a quick checklist that will get you off the ground in minutes. First, ensure Ollama is running and pull your preferred model. Second, use npm or Python to globally install your desired MCP servers. Third, configure your environment variables for any tools that require API keys, like Brave Search. Fourth, create a simple JSON config file telling your client where these servers live. And lastly, just fire up your client bridge to start the loop. It's that straightforward. Now, a really crucial pro tip straight from the developer community. If you are setting this up on Windows, you've got to watch out for path issues. The parsers in these bridge clients can easily choke on Windows drive letters and backslashes. So to avoid some incredibly frustrating errors, just make sure you use Unix-style forward slashes in your JSON config files. And there's another fascinating technical quirk regarding browser automation with Playwright. Beware of this one. Sometimes a second tool call mid-loop can accidentally spawn a brand new MC subprocess. Why does that matter? Because it completely resets your browser session and loses your place on the web page. Community members have noted that using a thin adapter server pattern fixes this by keeping the browser session alive independently across multiple tool calls. So definitely keep that in mind if you're doing web automation. And there you have it. We have explored the anatomy of local agents, the models acting as their brains, the clients serving as their nervous system, and the safety features that keep them perfectly in check. We've basically handed you the complete blueprint for private, free, and incredibly powerful AI automation. You have the models, you have the bridges, and you have the tools. So the only real question left is, what on earth are you going to build and automate first? Thanks so much for joining me on this explainer, and happy building.